Hello, my students and viewers all over the world, and chemistry learners, teachers of chemistry, tutors of chemistry, wherever you are, whoever you are, wherever you are watching this video. I want to send a greeting to you. If you find this video useful, as you watch all my past video, kindly make comments and let your comment be positive. If you find something challenging and you do not agree, you are also free to make some constructive criticism, which will be looked into, and possibly, if you are right, it will be corrected. Now, this is a topic on reaction mechanism. I have given lots of video on chemical kinetics and some other things, but in this video, you will be understanding what reaction mechanism is all about. I am your chemistry tutor, Akweji Honesty. Now, reaction mechanism, we need to look at it. I have my students, chemistry students I'm teaching, and some persons in my YouTube channels, and also comments from everywhere, people calling that they want to have detailed knowledge about reaction mechanism, and on that account this video is being done. Now let's go to reaction mechanism in full. In my earlier videos, I have always mentioned about writing an overall balanced chemical equation. But do you know that overall balanced chemical equation does not actually tell us much about how a reaction actually takes place? In short, in many cases, it merely represents the sum of several elementary steps. Okay, what I mean by elementary reactions, meaning a series of simple reactions that represent the progress of the overall reaction at the molecular level. You will understand as I progress in this video. So the time for the sequence of elementary steps that lead to product formation is actually called reaction mechanism. Okay, the reaction mechanism is a series of reaction or sequence of reaction of different elementary steps that have actually take place, which now actually lead to product formation. Okay, that is what is referred to as reaction mechanism. So those steps of reaction that have taken place which lead to product formation is actually called reaction mechanism. But the steps, those elementary steps, okay, those steps, each of the step that has taken place which we cannot actually see. What you see is the overall reaction in every reaction given to you, but there are actually some elementary steps that have taken place which lead to the overall reaction. Each of those steps are actually called the elementary step. How do I put it in a better way? Let me take an example of a reaction mechanism. If we consider nitric oxide, okay, nitric oxide in the presence of oxygen, which gives you 2NO2. This is what you see. Okay, you only know that this reacted with it and gives you the product, which is a final reaction. This is actually what you see. We know that the products are not formed directly. This product is actually not formed directly from the collision of two NO molecular formula with an oxygen molecule, because N2O2 is actually detected during the course of the reaction, which you are not seeing here. Okay, because you cannot see it, you will not know that there are actually other elementary reactions that have taken place, which now lead to the final product formation. Okay, let us assume that the reaction takes place via two elementary steps as follow. Okay, if we assume that this one reacted first to give you 2NO, like 2NO, okay, which rather this 2NO will first of all give N2O2. Okay, and this can be a step. Remember, this is the elementary, okay, step, as you can see. So that to give us this N2O2, that is, if this one reacted first, okay, two molecule of nitric oxide will give you N2O2, okay, so that this one now, what is formed as N2O2, now react with this oxygen, okay, will now give you a product formation of 2NO2. If this is our step one and this is our step two, these two, okay, step are actually the mechanism of this overall reaction. That means for you to react NO plus O2, okay, there are other elementary reaction or steps that have taken place that made this product to be formed, and those steps are actually this, and which is step one and step two. I want you to use this example to learn some things that I'm going to be explaining further. Okay, so the series of reaction that has taken place, okay, which is the elementary reaction that has taken place, or the series of steps or steps of step that have taken place, which now lead to the product formation. Okay, studying such kind of reaction is what we refer to as the mechanism of the reaction, which is the reaction mechanism. So from here that you from this reaction, the mechanism of this reaction is this one, but you cannot actually see it. What you only see is that this react with this to give you this. That is what you see. But in the background, there are elementary reactions that have taken place, which now help in this product formation. And how you will know is when you add this reactant together, okay, and this product together, you will see it will give you what you have here, okay, which will now give you back the overall reaction. This means that when you add the elementary steps or elementary reactions together, it will give you the overall reaction. Okay, this means that if this is my step one and this is my step two, how do I have my overall reaction? My overall reaction is gotten by adding the elementary reactions together. For step one, this is the reactant. I have 2NO plus step two. This is the reactant, N2O2 plus O2. Okay, for step one, this is the product, N2O2 plus step two, this is the product, N2O2. Okay, NO2, rather 2NO2, which means that this one, you cancel that identical species. When you cancel that identical species, what will be left to be what now? 2NO plus O2 to give you what now? 2NO2. This is our overall reaction, which is equivalent to what you were giving. Yeah, so this is teaching us that when you have different elementary steps, okay, which is the reaction mechanism, the mechanism of the reaction of the overall reaction, it means that when you add those mechanisms together, you will be having your overall reaction in any reaction given to you. Once the mechanism is given to you, add the mechanism together, you have your overall reaction. Okay, let's look at in this case again. Look at this reaction. Okay, the mechanism of the reaction is given, which is 2NO, okay, in this format, N2O2. This is our step one. We are told that our step one is fast, which then the second one, which is N2O2, okay, N2O2, which give us 2NOCl. And we are told that our steps two is slow. Okay, now the overall reaction is given to be the overall reaction is given to be 2NO plus Cl2 to give you 2NOCl. Okay, but the point I'm making is now these are the mechanism of this overall reaction. Okay, if the overall reaction is not given to you and the mechanism is given to you, how do you go about it? Once the mechanism is given to you, these are the mechanism of this reaction. Okay, and the overall reaction is not given to you. It's for you to add the mechanisms together, because the mechanism are the series of steps which you add up together to give you the overall reaction. Okay, so when you add up the mechanism, which are the elementary steps, okay, which are the steps of the reaction which make up the overall reaction, if you add them together, you are going to have this overall reaction. Let's go to that now. If you add this one, this is the reactant 2NO, plus this is the reactant N2O2. Then you have this is the reactant and product N2O2, plus what, this is the product here NOCl. You see, you add this one and this one here, you add this one and this one. When you do that, you cancel out identical spreadsheet, then you are left with 2NO, okay, to give you 2NO, 2NO, sorry, this one it has plus Cl2. Okay, do you get it? I hope you are seeing what I'm doing. There is there is plus Cl2 here. Okay, so that when you have your overall reaction, as you add this, which is this, you have this, which is this, you have this plus Cl2, and you have this, which is this, you have this, which is this. Okay, by the time you cancel identical species, you are left with what, 2NO plus Cl2, okay, to give you what, 2NOCl. Are you seeing now? Let me write it well. 2NO plus Cl2 to give you 2NOCl. You see now, it still gave you back your overall reaction. Look at your overall reaction. It gave you back the same thing. This actually tells you that in this reaction mechanism, you actually do not need to balance reactions stoichiometrically. You don't need to balance stoichiometrically by you putting 2 or 1 or 3 or 4 in the reactant or in the product. When you do the right thing by adding or subtracting, as the case may be, you will be having a balanced chemical equation. So you can see here that these are mechanism of reaction as and for this reaction, for this overall reaction. So if the overall reaction is not given to you, you can add the mechanisms together and you have your overall reaction. If you can see it very well, it is balanced. Okay, so with these two examples, like example 1, and I'm taking this one as example 2, I want to quickly identify some terminology used in reaction mechanism, which I will also be explaining. Terminologies like how to explain reaction mechanism, which I have done. I've talked about the elementary steps, which I've also done, but I need to talk about the elementary step. In the elementary step, and if it is given to you, sometimes they will say it is step 1 is fast, step 2 is slow. Sometimes they will say step 2 is slow, step 1 is slow and step 2 is fast. Okay, those are the types we can have under the elementary step. But just note that most times, okay, when it is a fast process, okay, that is when the reaction just started, because as reaction is consumed immediately, it will go very fast. Okay, so that means the reaction just started, and most time at that point it is usually a reversible reaction most time. But when the reaction is getting slow, that means it's gradually coming to an end, to giving you your product formation. And that time we can say the reaction is actually slow. So when you are giving the fast process or the slow process, you should know what it means. And then it also means that the fast process given to no if the fast process is not given to you, or the slow process is not given to you, and they just say step 1 and step 2, okay, and you see reversible reaction in one of them, as you have here, you see reversible reaction in one of them, that should quickly tell you that that will be a fast process in most cases, and that the other one will be a slow process. I don't know whether you understand, but in most questions, it is usually not given fast or slow, or rather, the reversible reaction will not be indicated. And when it is not indicated and fast or slow, okay, is indicated in the elementary step, then you can make that fast a reversible reaction. But understand that in some questions, there are some difficult questions where this principle does not work. Maybe because the examiner want to test your knowledge on how you can manipulate the reaction to having the correct final product of, I mean, the correct overall reaction, such that your rate law which you will be determining will be equivalent to the overall reaction given. I will be taking some examples if time permits me, okay? And I quite believe that you will understand. Okay, I want to talk about the reaction intermediate. Remember, I've explained this. So talked about this. I've talked about this. I want to talk about reaction intermediate. Let's go back to my example. Okay, how do you identify the intermediate of the reaction, or the reaction intermediate? The reaction intermediate, they are actually the species that appear in the reaction mechanism, but not in the overall balanced chemical equation. Please note that for this. They are species that appear in the reaction mechanism, but not in the overall balanced chemical equation. So in here, the reaction intermediate is present here. I'm going to point it out later. Here, you can find it in the mechanism of the reaction. You should not find it in the overall reaction. This overall reaction, there will be no intermediate present here. This is the overall reaction for this one. As we did look at it, there will be no intermediate present here, or reaction intermediate. You can only find the reaction intermediate in the mechanism of the reaction. And how do you know the reaction intermediate? We say they are present in the reaction mechanism, but not in the overall balanced chemical equation. Okay, and how you will know is that an intermediate is always formed in an early elementary step. Okay, this is the early elementary step. It is always formed in the early elementary step and consumed in later elementary step. You see, what is formed there is now consumed here. This N2O2 makes the intermediate of this mechanism. So the intermediate here in this mechanism is N2O2 because it is formed here and consumed. It is formed in the early stage of the elementary step and consumed in the later stage of the elementary step. Let's come here. How do you know the reaction intermediate? The intermediate it is the species that is formed in the in the early stage of the elementary step and then consumed in the later stage. So the reaction intermediate here is what now? N2O2. I hope you understand. In a simple term, reaction intermediate is the species that is formed. Okay, it is formed in the early step of the reaction, okay, of the elementary step, and then it is used up, consumed in the later elementary step. I hope with that you understand what reaction intermediate is. Some tests we just call it intermediate. They are both correct. If you look at this reaction, for example, okay, just look at this reaction. For example, I have this reaction like this. Okay, these are mechanism of reaction and produce A star. Okay, I mean A2 star as fast, and I have another one B plus A2 star, okay, to give me C plus D as what? The slow process. This is step one. This is step two. If you look at this one, now, how do you identify the reaction intermediate? It is the species that is produced and then being consumed. Produced in the early stage and then consumed in the later stage. So our reaction intermediate is equal to A2 star. Do you understand? Here, the intermediate is what? N2O2 O2. Okay? That is the intermediate here. The intermediate here, it is what? What is the intermediate? You must check the mechanism. It is also N2 O2. So identifying the intermediate is very simple, but note that in any question given to in a reaction mechanism, you must know how to find the intermediate. Okay, that is how to get the intermediate. The other thing you must know, the terminology you must know, is how to determine the rate determining step. That is the next one. So the rate determining step actually in a multi-step process of is one of the step is usually slower than the other. The slow step, as you have here, this is the slow step. Okay, as you have here, this is the slow step. Okay, this is a multi-step reaction. So you have three reactions taking place here. You also have three reactions taking place there because N2 is giving this is also giving this giving this is one, this giving this is two, then this giving this is three. Okay, now in a reaction where you have the slow push step, the slow step or the slowest step limits the overall reaction rate. And this step is called the rate determining step. Actually, it is the rate determining step that determine the rate law of the overall reaction. Rate determining step is the slowest step in the sequence of steps which lead to the product formation. So the rate determining step, actually it is the step, the slowest step that leads to product formation. Let me tell you, if you cannot identify the rate determining step in the reaction mechanism, you will not be able to even know the product that will be formed, because there are some trickish questions where the product may be hidden but your rate determining step is given to you. So what is formed in the rate determining step most time used to be the product of the overall reaction. Please note that. And also know that the rate determining step is the one that determines, it is the most important step, okay, in your reaction mechanism, because it determines how you get the rate law for that reaction. Okay, most time it is the slowest step in the reaction or called the slow step in the reaction. But there are also some questions that will come to you where you will be seeing the fast process as the rate determining step. It is so because the examiner only interchange and want to see whether you are intelligent enough to manipulate your reaction, then having the right product formation. In short, I have solved many questions, series of questions, where I discovered that this is just a manipulation from the examiner, and it is allowed in exams. Okay, just wanting to know whether you are intelligent, that is where your intelligent quotient is tested. So it is good you understand. If you cram reaction mechanism, the truth is that you are just working towards failure. Okay, so I will be taking some questions and then I will be explaining some things. Okay, but before that, if you are going to write the overall reaction of this now, how do you go about it? I wish that you are actually that I am having a feedback mechanism from you. Okay, how do you get the overall reaction from this? Having known that this steps are the mechanism of the reaction. Meanwhile, the overall reaction is not given to you. Most time in the question, they will ask you to look for the overall reaction yourself. What do? You add the elementary steps together. As simple as that. Okay? Addition of the elementary steps give the overall reaction. So what do? You say A plus A, then plus B plus A2 star. Okay, will give me what now? A2 star plus C plus D. Okay, if I am going to nullify, this will cancel the that is the identical species. That means I'm going to have having 2A plus B to give me what? C plus D. This is the simple overall reaction for this mechanism. Okay, this is the overall reaction, okay, for this mechanism actually. So that is how you go about writing your overall reaction, and also uh, writing your determining the reaction intermediate. Okay, and there's also another thing you must know. It's called the molecularity of a reaction. So which is the last step? Molecularity. The molecularity, okay, of a reaction is different from order of reaction. Okay, the molecularity of a reaction is the number of releasing species which collide simultaneously to bring about a chemical reaction. And I want to tell you, molecularity of a reaction is determined theoretically, and it is always a whole number. And you should understand that it's different from order of reaction. Okay, and in most questions, you are usually asked to determine the overall reaction, to determine the molecularity of each reaction. Okay, in molecularity, we have three types. We have a reaction can be unimolecular, or it can be bimolecular, or it can be thermolecular. I talked about number one. Okay, so that those are the types of molecularity we have. But before let me give a better definition of molecularity of a reaction. It is the number of molecules reacting in an elementary step. I think that is the best way I can give it to you. A number of molecules reacting in an elementary step. These molecules may be of the same, or they may be of different types. So each of the elementary step, okay, can actually be either a unimolecular as this, or a bimolecular as this, or a molecular. Okay, a unimolecular, which explains that an elementary step in which only one reacting molecule participates. Okay, so an elementary step in which just only one reacting molecule participates. For example, when you have A, okay, to produce P, and you are asked that what is the molecularity of this reaction, it is unimolecular, because only one reactant molecule is participating in this reaction. So this is a unimolecular. Okay, it is unimolecular. Please understand that it is different from order of reaction, even though it is a first order reaction, but it's different. Okay, because you get order of reaction from the rate law, and rate law is experimentally determined, but molecularity is theoretically determined. So you should understand that, so that you don't equate molecularity of reaction with order of reaction. Also, let me talk about bimolecular. Bimolecular is such that an elementary step that is involving two molecules, okay, two reactant molecules. Okay, when two reactant molecules are involved, either they may be the same or they may be different. For example, you have A plus A. These are two same reactant molecule. Okay, this is a bimolecular, because this one with respect to this is unimolecular, with respect to this is unimolecular. Bringing them together gives you a bimolecular. And in this case, you can have different reactant species. For example, you have A plus B to give you P. Okay, this is one. This is another one to give you product P. These are different reacting species. So this is also bimolecular because with respect to A is unimolecular, with respect to B is unimolecular. So bringing them together is bimolecular. I hope you understand. So the molecularity from any elementary step, you can know molecularity of the reaction. And of course, you can write the rate law. Okay, how to write rate law, you can go to my past video to know how to write rate law of each reaction. And I want to tell you, if you are working on, reaction mechanism, you must know how to write rate law. I will be doing some live example. Just know that you see all the past videos I have done on kinetics, go and know them. If you don't know them, you will have serious challenge in reaction mechanism. Okay, so let's go to thermolecular. How do you explain thermolecular? Thermolecular is actually an elementary step that in which an elementary step rather that involve, three molecules. Okay, it's reactions that involve the participation of three molecules, okay, in one elementary step. Okay, so in that case you can have three types. For example, you have the one of the same molecules, you can see, giving you product P. You can have of, um this and this will be the same, but the third participant will be different. Then you can have the three to be different, A plus B plus C, to give you P. In all of these, it is a thermolecular. That means this is thermolecular, which is TER, thermolecular. With respect to the unimolecular, when you add everything, it is thermolecular. So this is thermolecular. Why? Because three reactant molecules are participating here. Here, three reactant molecules are participating here. The difference between this and this is that the three reactants are the same. Here, two of the reactants are the same, while one is different. Here, the three are actually different. I hope you understand this. So you must know how to determine the molecularity of reaction. And when you know this, you will not be having problem any longer. But it is where you cannot be able to determine this thing. That is when you'll be having issues. Okay, I want to give a brief summary. I've talked about reaction mechanism. I talked about the elementary step. Elementary steps are actually the steps, okay, the steps of the steps that make up the overall reaction. Okay, without the elementary step, you will not be able to have the overall reaction. I think that is clearer. And in the elementary step, you have the slow process, you have the fast process, which may be given to you or may not be given to you. And that will require serious intelligence to be able to determine it. Okay. Yeah, I've also explained reaction intermediate, okay, that it is the one that is consumed in the early part of the elementary reaction, and now it is produced rather in the early part of the elementary reaction, and as it is produced, it is now consumed in the later part of the reaction. I've also explained to you rate determining step. In reaction mechanism, if you are not able to get the rate determining step, you will not be able to move forward in getting the overall reaction. I've told you that the rate determining step, which is the slowest step in the sequence of steps leading to product formation. As simple as this definition is, learn it. The slowest step, the slowest step in the sequence of steps which lead to product formation. I've equally spoken about overall reaction. Add all the elementary reactions together, you have an overall reaction. You don't need to balance anything. You don't need to balance it stoichiometrically. Leave it like that, it is balanced. And you have molecularity of the reaction. With that, you are again. But let me quickly talk about this. The molecularity. Here, these are the reaction. Okay, the reaction mechanism. Here it is so bimolecular. Here it is bimolecular. I hope you understand that. Let's go to this mechanism. Here it is bimolecular. Here it is bimolecular. Do you understand that? Okay. Then let's go to the here it is bimolecular. Here it is bimolecular. Do you understand that? Now, so we have the cases of unimolecular. When I take you check my next video, okay, you will see I'm going to be solving live questions that will determine how we can get all these details well. But you must understand what has been explained there. Your understanding of what has been explained there will help you in detecting others. I want to thank you for listening to my video. And if you have understood what I've taught, please make your comment and also like my video, share to others who are inquisitive to learn, share to chemistry students all over the world, share to chemistry teachers, professionals, and let them spread this video so that our world of chemistry will become as simple as anything. Many students are having challenges in chemistry, but with this video, I believe you will be having a relief in chemistry. Thank you. I remain your tutor, Akpeji Honesty. Bye.